So these are your last set of notes for the school year. So your FLT is to be able to calculate the probability of an event under the standard normal curve. So I'm going to start off the notes with some review from IM1. So for starters, let's start off with defining what a mean is. So a mean is the average. And to find the average, you add up all the numbers, then divide by how many numbers there are. In stats, there are two main symbols that we use for average. The first one is X bar that you might recognize from IM1. And then also we do use mu. It kind of looks like a curly M/U. These are basically the same thing. There's a slight difference between them. This is a sample mean, this is the population mean, but that's not really something that you need to know. You will learn more about that if you do take stats and AP stats next year. Standard deviation is basically how far apart your numbers are in a data set. So how far apart numbers are in data set. So if you have a data set where the numbers are far apart from each other, that means you have a large standard deviation. If you have numbers that are super duper close to each other in a data set, that means that you have a small standard deviation. The symbol that we use is sigma, that you might recognize from IM1, and it looks something like that. So let's first start off with an IM1 problem. Suppose the height of women between the ages of 20 and 29 are normally distributed with a mean of 64.3 and a standard deviation of 1.92. So mean is 64.9 or 64.3, standard deviation of 1.92. So you know that the mean is X bar, 64.3, standard deviation using sigma is 1.92. If you remember from IM1, which is 3 years ago, the middle part here is our mean. So I'm gonna put 64.3 there. And we're gonna go ahead and find one standard deviation away. So 64.3 plus 1.92 is 66.22 plus 1.92, 68.14 plus 1.92, 70.06. I'm going to go to the left now. 64.3 minus 1.92, 62.38 minus 1.92, 60.46. 3 standard deviations away, 58.54. So if I want to find the percent of women who are between 62.38 and 68.14, I'm going to look for 62.38, which is right here, and 68.14, which is right here, and I'm looking for the percent of women in between. So that means now I'm going to look at the percentages. There are 3%, 34 plus 34 plus 13.5, which is 68 plus 13.5, and you get 81.5%. Find the percent of women who are shorter than 58.54. So I'm going to look for 58.54, which is right here. If I'm looking for a woman who are shorter, that means I care about the percent to the left, and it's only this guy right here, 0.15. So that's your answer. Hopefully, you might remember this from IM1. It was a while back. But we are going to go ahead and take this one step further. So let's say like I asked you a question and I said, oh, you know what? What's the percent of women who are at least 65 inches tall? And if you look at the curve, you see that 65 isn't exactly one standard deviation. It's somewhere like right here. Now, what we're going to learn today is how do you find this percentage and how do you find that exact percentage? So there is one key formula that you will have to memorize. It's finding the z-score. And I'm going to explain more what the z-score means, but z equals x minus the mean all over the standard deviation. So the x is the data value, this mu is the mean, and this guy is a standard deviation. The z-score always gives the area to the left of the curve. Okay, so what does this all mean? So when you are looking for the z-score, you have this fancy table. I also attached the table to make sure you also print this out. It looks something like this. So notice here that these values, obviously you never have to memorize. If you do take stats next year, you'll be given this on the AP exam and so forth. The z-scores are all here, and these right here are the actual percentages. These are positive z-scores. You turn it over to the other side, then I have negative z-scores. So I'm going to first teach you how to read this. So if I ask you to find the probability using the z-score of 0.92. So 0.92, I'm going to use the positive side. So you always start off with the left column here. So I'm going to look for 0.92. So 0.9 is here. I want 0.92. So there's the 0.02. So 0.92 would be this guy right here, 0.8212. And this could also be converted into percentages, which is 82.12%. Now to find the z-score of 2.34, I'm going to again stay on the positive side. There's 2.3. You always start on this column again. 2.34. That means I need to go over to this column right here, and that would give me 0.9904. Right now, I'm just asking you to read the z table or percentages. Normally, we do keep it into decimals. Z equals negative 0.03. So it is negative. That means I'm on the other side. Negative 0.03. So I need negative 0.003 would give me this column right here, which is 0.4880, because the 3 is right there. So 0.4880. Negative 3.49. Negative 3.49, there's negative 3.4. I need to go all the way to get to the 0.9, and that'll give me 0.0002. So that's how you read the z table. Now let me show you how we actually use it. So let's say we have a test, and the test scores are normally distributed with a mean of 81.2 and a standard deviation of 3.6. A randomly selected student scored below 74. So the very first thing you want to do is you actually want to find the z-score. So on the front, z equals x minus mu all over the standard deviation. The value that they give you, that's always going to be your x. So z equals x minus mu all over the standard deviation. Your x is 74. Your mu is your mean, which is 81.2, all over the standard deviation, which is 3.6. So on my calculator, I'm going to do 74 minus 81.2 divided by 3.6, and z equals negative 2 flat. So on my z table, I need negative 2. So I'm going to go to negative 2.00, which is 0.0228. So that means if I were to convert it into percentage, I move it 2 times to the right. So that means 2.28% of students scored below a 74. That is how you use your z table. Let's try another one. A randomly selected student scored above 88.4. I'm going to actually take a step back and show you what this graph looks like. So our mean is 81.2, and then we want it below 74. Okay, and then we found our z-score, and we got negative 2. And then under the z-score, we got 0.02228. So this right here is 0.0228. So I didn't draw it to scale, but that's what the z-score shows. Remember, the z-score always shows to the left of the curve. And because we want below 74%, that means we do care about the left-hand side. Okay, so let's say I have above 88.4. So I guess we'll start with the actual curve this time. We'll put 81.2 and we'll put 88.4 over here. So for starters, I need to figure out what the percentages are, and to do that, you need to find your z-score. So x minus mu over standard deviation. X is this guy right here, 88.4. Your mu stays the same at 81.2. Your standard deviation is 3.6. 88.4 minus 81.2 divided by 3.6 is positive 2. So under positive 2, make sure you're on the positive side. I'm looking at 2.00, so that's 0.9772. So that means, remember, the probability is always to the left. This is all 0.9772. Be careful here though, the question asks above 88.4. So actually we care about this side of the graph. We care about this tail. If you remember, the total area under a curve is 100% or just 1. So to actually find this part right here, we need to figure out what's 1 minus this right here. 1 minus 0.9772 is 0.0228. Which is actually the same answer we had in our very first example. So that means that our final answer is 2.28% of students scored above an 88.4. So remember, the z-score always gives you the probability to the left of everything. So you have to be very careful of what's given to you or what's being asked. The probability of a student selected is between 81.2 and 84.8. Okay, so between 81.2 and between 84.8. If you remember, 81.2 is our mean, right? Remember, the mean is exactly 50%. So I know that this right here is going to be 50%. And we don't know where 84.8 is at yet. We don't know what this probability is. We need to figure out what this probability is using the z-score. So I'm going to take 84.8 minus the mean of 81.2, divided that by the standard deviation. 84.8 minus 81.2, hit enter, divided by 3.6 is 1. So my z-score is 1. So on my table here, if I look for 1, this is going to be 1.00. That's 0.8413. So 0.8413. So let's go back to what we just figured out. 81.2 is smack dab in the middle. So 50% of kids got an 81.2. 84.8 is people who got 84.8 and below. Because remember, the z-score always gives us to the below. So this right here is 84.13. But remember, the question is asking between 81.2 and 84.8. So actually, we only care about this number right here. Right, we only care about those students. This 0.8413 is 84.8 and everything below. So to figure out which is this part is, well, we know that this part right here is 50%. We know all of this is 84.13%. So to find just this part, we have to subtract it. So 0.8413 minus 0.5. And you get 34.13%. So 34.13% of students scored between an 81.2 and an 84.8. I know it's a lot of information, but let's look at one more example. A randomly selected student scored between 77.6 and 88.4. So my mean is still 81.2 from the very original. And here's 77.6. right? 77.6 is going to be the left, and then 88.4 is going to be somewhere way up here. And our goal is to figure out the in-between right here. So first, we need to figure out what this part right here is. So to figure that out, we're going to find the z-score of this. So 77.6 minus 81.2 divided by 3.6. 77.6 minus 81.2 divided by 3.6. Your z-score can be negative, so your z-score is -1. When your z-score is negative, make sure that you're on the negative side. So -1.00 is going to be this right here, 0.1587. So students who got below a 77.6 is 15.87%. We're gonna go ahead and do 88.4. Actually, we already did 88.4. We did 88.4 with question number 2. So I'm just gonna go ahead and just copy down what we did earlier. So with 88.4, we got a z-score of 2. And then from there, we said that it was 0.9772. So that means all of this right here is 0.9772. So 97.72% of students scored 88.4 and below. Now we only care about the between 77.6 and 88.4. So we only care about this part. Z-score always accounts for everything to the left. So we only care about this yellow part. So we know that this is 0.9772. And we don't care about this green part right here. So I'm going to subtract that part off. Because if I subtract this part off, then I am just left with the highlighted yellow part. So 0.9772 minus 0.1587. That gives you 81.85. So 81.85% of students scored between the 77.6 and the 88.4.